In this video, I would like to teach you logarithmic differentiation, and I'm going to do it by applying the method of logarithmic differentiation to this example right here. So we'd really like to be able to compute f prime of this function, and we could do it. We've got like a quotient on top. We've got a product. I've got this like squared right here, which wouldn't be like so bad. But it'd be a lot of writing, right? Low D high minus high D low, draw a line and square below would happen. And we'd make it through. But I wanted to show you the method of logarithmic differentiation because it gives us a nice tool to be able to write down derivatives of expressions like this, where I've got these like products and quotients. And in particular, I've got product and quotient of things which are polynomial in flavor, and that means that this logarithmic differentiation is going to be readily applicable. So, key observation that I would like to make with you, here's my key observation 1, is that dx of the natural log of f of x is equal to, well, that's just the chain rule applied to the natural log function. So I've got a thing on the inside right there. The derivative of the natural log is 1 over the blob. So f of x goes right there. So if f was just x, we'd be done. But now I have to chain out the derivative of the inside. And then I'm going to erase these extra box marks in just a second here. So I have to chain out the derivative of the inside of this thing and multiply against it, which I'm going to put on top as f prime of x. So the derivative of the natural log of a function is the derivative of the function over the function itself, which is like, wow, this is crazy. So all you have to do is take the derivative of f and then just divide by the thing you started with, and you get the derivative that you were seeking. As far as chain rule rules for doing functions, this one to me is one of the most fascinating. So let me put that all on one line again. The natural log of f of x prime is equal to 1 over f times chain out the derivative of the inside and pick up an f prime. Okay. Observation 2 that I want to make with you is that the natural log of a times b is equal to natural log of a plus natural log of b. So what we're going to do is we're going to take the natural log of both sides of this expression of the function that we're going to want to take the derivative of. And since this thing is just a product, the quotient's just a product with a negative power, or I could put a divided by and get a minus sign right here, we're going to be able to take the derivative of the right-hand side here super easy by taking the log of both sides, and then just using rules of logs, and then I'm not going to have to deal with the quotient rule or anything like that, right? So I'm going to erase these two reminders, but keep them in the back of your head. Okay? So let's take the natural log of both sides of this equation right here. So if f of x is equal to that, then the natural log of f of x is equal to the natural log of x plus 1 squared times 2x squared minus 3 times x squared plus 1 to the minus 1/2. Okay. So let's use the rules of logs to split that thing up. I'm going to carry that left-hand side with me. So this is the natural log, again, of the entire thing inside. I put braces right there to highlight that fact. So the natural log of the product is the sum of the natural logs. And then this 2 gets to come down front because of the rule natural log of a to the b is equal to b natural log of a. So powers inside become coefficients in front in the world of natural logs. So this is equal to 2 natural log of x plus 1 plus natural log of 2x squared minus 3 minus a half of the natural log of x squared plus 1. Yay, I ended up all on screen. Better use some parens. Okay, so there's a hidden 1 right here because there was a 1 right here. This 1/2 came down front and made it right there. Now I'm going to take the derivative of both sides. On the left-hand side here, I'm going to get f prime of x over f of x. That was our first tip here, our first realization. So the derivative of natural log is 1 over, chain it out. And then we're going to do the same thing over on these things right here. The derivative of natural log is 1 over, and chain it out. So this is going to be 2 over x plus 1. And then we're going to chain out the derivative of x plus 1, but that's just 1, so I'm not going to write it. Plus, I'm going to start with an over and put this thing down there. So 2x squared minus 3. And now I'm going to chain out the derivative of this thing and put it on top. 4x minus 1 over 2x squared plus 1 times 2x. And let's simplify this expression a little bit by making those 2's cancel to 1. 1 times anything is just anything. So I pick up that. I'm not quite done. I've got f prime over f. And here's our original expression for f. So then finally, in my last line here, it's not going to be like that great of a... it's not going to simplify really at all, right? But I'm just going to multiply by f on both sides to cancel f. So that f prime of x is equal to the quantity 2 over x plus 1 plus 4x over 2x squared minus 3 minus x over x squared plus 1 times this whole thing right here. Times x plus 1 squared, 2x minus 3 with a square, divided by the square root of x squared plus 1. And we're there. I'm just going to delete my extraneous paren. And I'm calling it good. So if you're approached by a complicated expression involving product and quotient and stuff like that, then you can spare yourself doing the product and quotient rule by doing what's called logarithmic differentiation. So this process was called logarithmic differentiation. Step 1 was log both sides. And then step 2 is differentiate. There's no way I'm going to squeeze the whole word in there. And then 3 is multiply by f on both sides to clear the denominator on the left-hand side, and you've got yourself the derivative. So pretty cool method. Arguably simpler than doing the quotient rule. It looks really different. It looks really, really different from what would have happened if we just did the quotient rule on that. Like, it looks super different. So, thanks for watching. I hope you enjoyed that. Go ahead and put that in your little belt of tools. And next time you see a product like that, give it a try. Thank you very much. Bye.